Alright, so this unit is about geometric sequences. So our last one was arithmetic. We were adding and subtracting. If it's geometric, it's multiplying. But a lot of the notation is the same. Like A3 still means third term. This time we have R. So R stands for the common ratio. And it's called our multiplier. So because we're multiplying, our standard equation is going to be an exponential equation, meaning it has an exponent. So let's go through and let's get an equation. I want to show you how to get the standard form equation, and then it'll help us go through the rest of the problems faster. So we're given the third term. So I'm going to skip down to the third term is 1/3. So this is the term number, and we call that n. Okay, so our third term is 1/3, and our ratio is -3. So that means if I want to get to the fourth term, actually I don't want that line there. I would take the previous term times the ratio. Okay, and if I want the fifth term, I would take that term times the ratio again. See the pattern? Times the ratio again. So for this sequence, it's kind of different because we're starting at term 3. But if I were to start with the first term, my equation would be take the first term, A1, times the ratio to the n-1. So for this one, let's go backwards and get our first term. So see how we're timesing by -3? We're going to divide by -3 to go backwards. So that's -1/9. And then do it again. That's +1/27. So our equation for this sequence would be 1/27 times -3 to the n-1. And let's just check, the third term should be 1/3. So if I take 1/27 times -3 to the n, which is 3, 2 minus 1. Oh, that should be 3 minus 1. We get -1/3. So something is off because it should be positive. So let's go change this to a negative. So this one should actually be negative. That will be positive. That will be negative. Okay, so on these ones you can count. Like we want the 9th term, so we could just keep going. 7, 8, 9. Or we can use our equation and put 9 for n, which is 243. Right here. So this one, find the next term in the geometric sequence. So this time we're not going to write the equation because we're only going one term over. But if you want to find the common ratio, which we do, we take the second term divided by the first term. So this is the first term, this is the second term. So second term is 1792 over 405. Big fractions on this one. Divided by the first term, 7168 over 1215. So 1792 divided by 405. I'm putting these in parentheses because I want to keep them together. That whole fraction goes together. And now this whole fraction is going to go together. And that comes out to 3/4. Okay, came out nicely. So what that means is to get from the first term to the second term, we're timesing by 3/4. And then we can even check our ratio. Let's say I enter the second term and I multiply by the ratio, which is 3/4, I should get the third term. And I do, 448 over 135. And then to get the next term, you just do the same thing. You would just keep multiplying by the ratio. So this one is 112 over 45. That's our next term. All right, calculate the 87th term, and we know the 39th term, and r equals -1. So for this one, we want to get the first term in our equation. So here's our standard equation. an is a1 times r n minus 1. So for this one, we're going to have to solve for the first term. So we're going to use n as 39 to figure out what a1 is. So a of 39, 39th term is -17, equals first term times the ratio, which is -1, to the power of 39 minus 1. And you can type that in if you're not sure. -1 to the 39 minus 1 is +1. So -17 equals a1 times +1. Well, a1 times 1 is just a1. So the first term is -17. So we're going to put that in our equation. And now we want to find a87. So this time n is 87. The first term is -17. The ratio is -1. And n is 87. So in our calculator, this time we have -17 times -1 to the power of 87 minus 1. Oh, see how I had to put that in parentheses? There we go. So this one is -17. And that makes sense because we're timesing by -1 or +1. So our series is just going to go back and forth. For the geometric sequence, find the two missing terms between -1 and 1 over 64. So for this one, we don't know what r is, but we know if we take -1 as our first term, so term number. If we want our second term, we're going to take -1 times the ratio. If we want the third term, we're going to take -1 times the ratio times the ratio. The fourth term is 1 over 64, right? But we get that by taking -1 times r times r times r. So that gives us 1 over 64. So this is an equation. -1 times r, 1, 2, 3 times, equals 1 over 64. So let's solve for r. Divide both sides by -1. So r cubed is -1 over 64. And then to get rid of a cube, you take a cube root. So we're going to cube root both sides. So I have the cube root of -1 over 64, which is -1/4. So that's how I'm going to get from term to term. I'm going to take -1 times -1/4, which gives me +1/4. And then we're going to times by -1/4 again. So -1 over 16. And if you multiply by -1/4 again, you get 1 over 64. So these would be our two missing terms. Find the next two terms in the geometric sequence. So we're given the first three terms, we just need to continue. So we need to figure out what's r, what am I timesing by? And remember, you take the second term divided by the first term. So negative 2 over 15 divided by 1 over 5. So negative 2 over 15, I put that in parentheses just so it stays together. And then 1/5 gives you negative 2/3. So r is negative 2/3, that's your multiplier. So to get to the next term, do 4 over 45 times negative 2/3, which is negative 8 over 135. And then same thing, you just keep multiplying by that same thing. So negative 8 divided by 135 multiplied by negative 2 over 3, which is 16 over 405. So it would be this one. Alright, the following geometric sequence is missing 4 terms. Identify any of the following answers that fit. More than one may be correct. So this one we have to set up an equation again because we don't know r, and we don't know the second term either. So you've got to think, if I start with term number 1, it's 224 over 1215. And then to get to the second term, I'm going to take that and times by r. To get my third term, I'm going to take that times by r again. Fourth term, take that number and times by r again. Do you see the pattern? To get term 5, I would times by r again. So I'm up to 4 r's. To get the sixth term, I would be timesing by r 5 times. But I know that one, it's 7/5. So in order to get 7/5, I take 224 over 1215, and then I times by r 5 times, so r to the 5th. So what this does is it creates an equation that we can solve for r. So let's get r by itself, so divide by 224 over 1215 on both sides. And that's going to give me r to the 5th. So let's see. 7/5 divided by 224 over 1215, which is 243 over 32. Oops. There's your notes. Okay, so r's not quite by itself. We have r to the 5th power. So the opposite of r to the 5th is a 5th root. Whatever the exponent is, you can take the root of that. And it should come out nicely, because those numbers, the 5th root. So 5, and then 243 divided by 32. So 1.5 is r. And I'm just going to actually leave it as 1.5. Okay, so my second term would be 224 over 1215 times 1.5. So 112 over 405. That's the second term. The third term you would times by r again. So times 1.5. 56 over 135. Fourth term, you times by r again. And at this point you could use powers if you want. This would be to the third power. So 28 over 45, so not that one. The fifth term, it'd be r to the 4th. 44 over 15. Oops. So not that one. And then we're done. So those would be the two that you would select. And that's it for this section. Good luck.